Hey everyone, welcome to another game development episode where we're recreating The Legend of Zelda in Game Maker. One of the things that really makes Zelda feel good when you're controlling it is the fact that the developers aligned the Link to a grid when walking. So when he's walking around and he goes in certain directions, he's automatically aligned to the grid, and this makes it much easier to navigate through these trees in this case. And especially if I were to go over here where the cave is, and I go up, I'm automatically aligned to it. I didn't have to sub-pixel try to move him to make sure that he aligned to it. It just happened. Same thing when I go back down here, I align fairly easy. And so what's happening here is they align Link to an 8x8 grid. So each of these tiles here, these trees are 16 by 16. So when I go up right here, he's going to align halfway on the tree, which is 8 pixels. And then I do this and he aligns directly onto the tree, and I go a little bit further and I align on the next 8 pixels. And so what's happening is you can actually do, a pixel movement here, but as soon as you go the other direction, so if I go in the X direction, he gets aligned on the grid on the Y. So whatever direction you point him to, the other direction gets aligned correctly. And this happens automatically. So we're going to do that to make our game feel better. And it's going to be fairly simple, what we're going to be doing. We're going to go to our object player. It's down here in objects in the player folder. And we're going to go to the step event and right here. And what we're going to do is we're going to go down where we have the case up. There's down, left, and right. And so we already have the movement called Vy and Vx. This is the velocity in the X direction, velocity in the Y direction. Now currently, if we're going up, we didn't care about the X direction. We only cared about the Y. But now we want to deal with the X direction. So what we're going to do is we're going to add a new script. We'll go ahead and name it right here. We're going to say call align to grid. And what we're going to do is we're going to pass in the X value, and we're going to say, where do we want to align to? How many pixels do we want to align to? In our case, it's going to be 8. We want to align to 8 pixels, and that's going to snap it back to the grid. So this is going to return a value that says, hey, move in the X direction to align Link to that part of the grid. And we'll do that for all the directions. Well, let's go ahead and write this code real quick. So we're going to go over to utilities here in the scripts, and we're going to add a new script. Let's move that over. We got aligns a grid here, and let's go ahead and do the backslashes here, and we're going to pass in the value that we said and align to. So this is the script that we're going to write to. And so what we're going to do is when we get the X value or Y value where Link is that gets passed in here, we want to just check to see where it is on the 8 subpixels. So the way to, let's bring up the game again. So if you pretend this is the 16 by 16, what we're going to do is we're going to say, hey, tell us where Link is on these sub 8 pixels. So if I pass in the X value, it's going to say, is it on the 0 pixel, the 1, 2, 3, 4, 5, 6, or 7 in this X direction, and the same for the Y direction. That's what we're going to do. We're going to check where we are, and depending on where we are, if we're closer to 0, let's snap them over to 0. If we're closer to 8, let's go snap them over to 8, and that's what we're going to do here. So we're going to create a variable called var val, so it's for the value that gets passed in, and we're just going to make that equal to argument 0. And we're going to create a variable called align to, and that's going to be argument 1. So these are the values that are passed in. Now what we want to do is we want to find that number 0 through 8. Where is he on that? And the way we do that is we're going to create another variable called difference, or diff. And we're going to make that equal to val mod and align to. Mod is a built-in function that allows you to get the remainder of something. So this is going to divide 8. If we pass in 8, it's going to say whatever x is, 339 divided by 8, what's the remainder? And that's going to give us a number between 0 and 7. So returns a number between 0 and 7. Okay, the next thing that we want to do is we want to find the halfway point between 0 and 7 in this case. And it's not always going to be 7. Let's say we use this function and we passed in 16. It would be and whatever align to is. How about that? So that's what that actually going to be. And so next we're going to create a halfway point between 0 and whatever that number is. So we're going to say halfway is equal to, and now this is going to be a little bit funny. We're going to say align to -1. And since we're dealing with 0 to 7 in this case, on the pixels that we actually want to align to, we need to subtract 1 from it. And then we're going to say div 2. So we're going to divide that number by 2 so we get the halfway point. So if we passed in 8, it's going to take 8 minus 1, and that's going to be 7 divided by 2. And it's going to give me a rounded number without remainder, so that would be 3 in this case. And that's the halfway point. We need that so we can do this next part, which is we're going to say if the difference, the number between 0 and 7 is greater than the halfway point, then we want to snap the, we want to return the number that's larger. So we're going to say return align to minus diff. So since we passed in 8 and we're going to subtract whatever here, let's say we were on the second pixel, it's going to say 8 minus 2 is equal to 6. And that's how many pixels to the right or down that we need to move. Else, we're going to just return the difference. We're going to say return diff. Oh, no, we're going to return a negative diff because we're going to subtract it. So if the difference here was 2, and that is less than the halfway point, we're just going to subtract 2, and that's what's going to get returned. So hopefully you followed along on that. Okay, so now we're going to just copy this for all the values. So for the next VX, we're going to go down to the down, and we're going to replace that with the same exact thing. So wherever we are on the X, we want to align it to an 8-pixel grid. But when we move left, we want to change the VY. So we're going to replace that, and we're going to say Y. And we'll copy and paste that as well. We're going to go down to the right, and we're going to replace that as well. Okay, so again, this is going to return how many pixels we need to move in the Y direction to align it to the 8x8 grid. Let's go ahead and test this out. Okay, so the way to tell is if I press up, he will seem to snap in a certain direction. So. And he is. It's a little bit hard to tell because I don't have anything to compare it to, but you notice when I walk up, I'm walking right up to the rock. And if I go up a little bit and I do this, I'm going to walk right up to this rock too. And I should be able to do the same thing here. And I should be able to do halfway through the rock. So this is working. So this was what we were going to cover today. I just wanted to get the new align to grid feature in. That allows us to move. And it's going to really help us when we're dealing with stuff like the caves and moving around. It's going to feel a lot better. In the next episode, we're going to cover fixing the collisions. Because of what we just did, we also need to fix some collision checking, and we'll do that. In addition, I don't know if we'll cover it all in the same episode, but we're going to change the masks for Link. Because right now, the mask, and what I mean by mask is it's what is used to check for collisions. We need Link's mask to check for collisions against rocks and obstacles to be a 16 by 16 so he snaps correctly and he stops correctly. Right now, his collision mask is slightly smaller. So I'm going to show you guys how to do multiple collision masks because we want a small collision mask for dealing with enemies. We don't want it to be too big, but we want a big collision mask for dealing with rocks. All right, that's it. If you guys have any trouble, ask questions in the comments. Also, the code will be downloadable on the Patreon page. I'll provide that link below. It's all free. Take a look at it, and good luck. I'll see you guys in the next video.